Hey everyone, my name is Ali and I'm here joined by...
And I'm Afkhami. We'd like to talk to you today about time travel and the space-time continuum. So basically, time travel, as we know it, would either be going back in time or accelerating our travel from the past to the future. So how we do this is by usually either by wormholes or by using negative energy. The most probable way of time traveling is by actually time traveling to the future and not to the or past. This is because the only way to actually travel to the past mathematically is by using Kurt Gödel's timeline,
which is actually a circuit and curve-like timeline which continues and never ends. And the beginning of it is what you know called Big Bang. And also we could say that traveling in time and going to the past is very dangerous, and it's hard because, as an example, imagine that you go to the past and you prevent your parents from meeting. Then you won't even be born and you won't go and stop them from meeting. So
basically it's a causal loop. To be able to go back to the past and, for example, kill your grandfather, you need to first be born to do so.
And if you kill your grandfather, you will never be born. You will never prevent your grandfather from living, and so nothing will happen. In definition,
so basically, causal loops are loops that cause themselves, and if anything goes wrong in this chain, they can no longer happen. So you need to be there for you to be doing that thing, and if you're not there, then the causal loop stops. And a good example of causal loop is the woman, the scientist, the bookshop, and the production. A woman buys a book about time travel and goes home and goes into a time machine and goes 1 year into the past.
And then gives the book to a scientist. The scientist likes the book and rewrites it, gives it to a bookshop, and then again the woman comes and buys it. So this is the causal loop.
So actually, as you know, the infinity symbol is a psi base 8. How it's explained in causal loops is a woman, a bookshop, a scientist, and a production.
The production goes to the bookshop again. The woman buys it, gives it to the scientist.
The production gives the book to the bookshop gives it to the woman, and the woman to the scientist. And that is the basics of the infinity symbol, or a causal loop. And we'd also like to talk to you about wormholes. Put it down. Wormholes are our most convenient and our most likely way to travel to the future. And how it works is by expanding space-time behind this spacecraft and contracting it in front. It would open a gateway to accelerate ourselves from the past to the future. If we go with Kurt Gödel's timeline, eventually, no matter how further into the future we go, we'd eventually get back to X. But if you use just a wormhole theory timeline or just a normal timeline, we'd eventually get to the end of time. And here it's explained, if you want to go from point X to point Y or Y, it would usually take, let's say, 100 years. But if you want to slow that time down using a gateway or a wormhole, you have to contract and expand space-time.
But using negative energy, which contracts the past and expands the future.
Yes.
Or the opposite.
As Einstein says, time runs differently depending on its frame of reference. This means time passes at different rates and for different observers depending on their speed of travel. So let's say there's two twins, one on Earth and
one on a space shuttle.
It's let's say the ISS. The ISS is orbiting the Earth at 17,500 kilometers per hour. It will eventually lead to a time dilation of 0.000062462.
In other words, it means that the twin in the space shuttle will be 0.0002646 seconds
Per
younger than his twin
Every
on
day-
Earth.
Every day that the other twin orbits the Earth, he's actually getting this amount of time dilation. So let's say after a week, he'd be ever so slightly younger than the twin on Earth. But,
Something like 1 second.
yeah, but if the twin on the ISS is actually moving at 99.9% of the speed of light, he's actually having a time dilation of 4.5%, which means after 5 years, the twin traveling at 90% of the speed of light will be still 5 years old, but the twin on Earth will be 110 years old. So the only perceivable way we can see back
And
into
that's
the past,
all not even 1% of the speed of light.
no, 99.9% of the speed of light would be 110 years. So the only way we'd be able to see back in time perceivably is by placing a large mirror that we always make sure faces the Earth 0.5 light years away from us. This will cause actually the mirror to get reflected, like the light from the Earth will take half a year for it to go to the mirror and get
And
reflected
half a
and
year
get
for
back.
it to come back.
Yeah.
So if you look at the mirror and you are able to see Earth, you are actually seeing a picture of Earth which was like for 1 year ago.
Reflected for a year. Reflected for a year. So this is a live feed of our Earth. And one more thing I wanted to tell you is about wormholes. So as Kip Thorne and Paul Davies explained, wormholes are theoretical threads that connect two points in space-time. And the threads are so twisted that they are similar behind the space-time they bend. This requires a lot of energy and is being attempted at the CERN Super Collider at Geneva. And it's being attempted by colliding two electrons at near light speed. This will definitely immediately collapse into a black hole.
Unless if you use negative energy by theory,
But
which
it's not
helps
practical
to contain and control the energy for it not to collapse and make a black hole to destroy the whole universe.
But it's not technically yet practical. It's only a theory.
Yes.
Thank you for listening. This has been our presentation about time travel and the space-time continuum.
Yes.